Hello. Good morning, everyone. I cordially welcome our esteemed School of Environmental Science and Engineering, IIT-Kharagpur. Honorable Vice-Chancellor, Sir, Honorable Chief Advisor, Professor Mihir Kanta Chaudhary in absentia, Chairperson Academics, Dean Academics, Senior Faculty Members, my dear friends, colleagues, and all my dear students. It is a great pleasure for us to have amongst us Professor Mukherjee today, who has an elaborate achievements for himself to enlighten us. Thank you for your acceptance in gracing us with your presence, sir. May I request Dean Academics, Professor Ankur Ganguly, sir, to felicitate our distinguished guest. Dear students, painting by our very talented fine arts students, a Fulam Gamusa, token of love from Assam. And 2 books, Dr. Pansari. Groundwater Security of India, Interplay of Science and Policies. Followed by the talk, we will have a Q&A session. I request all of you to sit patiently through the session and note your questions for the speaker at the end. Proceeding with the agenda, may I request Chairperson Academics, Professor Dr. Alok Kumar Buragohai, sir, to deliver the welcome address. Sir.
Esteemed Vice-Chancellor, Professor S.P. Singh, our very distinguished guest this morning, Professor Abhijit Mukherjee from IIT-Kharagpur, my distinguished colleagues, Professor Ganguly, Professor Mipun, and all others, my dear students and scholars. This morning, today, in fact, is a very important day for us. It is not just a lecture. The lecture is of tremendous significance in the context in which it is being organized. Today, we are launching a laboratory for one of the very important and emerging subjects called geology, and I'm sure it will grow. And what is very important is that on this inauguration of this important department, we have a very important personality of the subject. Professor Mukherjee needs no introduction. He is a Bhatnagar Prize, Santi Swarup Bhatnagar Prize award winner in art, atmospheric, and ocean sciences for his outstanding and remarkable work in groundwater, contamination of groundwater, arsenic, and also various technologies to locate, detect groundwater aquifers, if I am not wrong, sir. And we are truly privileged to have you with us. And coming to the topic that has been chosen for this oration today by Professor Mukherjee, the groundwater, the status, the science and technology that go along with it, and the policies, most importantly. And as you are aware, that I think our country has world's one of the largest populations, but with only just hardly about 4% or something of the groundwater to feed us. So that is the scenario. And on the top of it, we are over-exploiting groundwater. I do not know how many of you have taken any interest in the next building next to us, which is the Central Groundwater Board. Central Groundwater Board has been constituted in 1970, one of the 18 boards in the country, and the one in the northeast is located next to us. I call upon the geology students to visit there, talk to the experts, and see what reality we have as far as groundwater is concerned in this part of the world. And if I understand rightly, we are identified as being located in one of the most critical areas as far as groundwater situation is concerned. And what is very important is this, that there is hardly any policy framework, legal teat to manage it properly, the way it should be. And that is the reason we are over-exploiting. And mostly 80% of the groundwater, if I am again not wrong, sir, is for domestic reasons. It's not for industrial reasons. So it is us who's at fault. And water is a commons, common. It's not a public good. It's not a private good, it's a public good, which is known as the commons. Everyone has a right to have it, but right with responsibility, judiciously. Okay? So, and ecology, as you know, in the context of climate change, ecology doesn't respect political boundaries. So therefore, if you misuse groundwater reservoir across the border, its impact will be felt and suffered by you and us. So therefore, when he will be talking about policies, I'm sure he will be talking about water diplomacy and science diplomacy, which has become an integral part of international geopolitics. So I will not prolong. This is for the expert. I don't hazard the risk of stepping into the zone of expertise of an expert sitting in front. But these are of general concern for all of us. Every one of us is concerned with water. Without water, there is no life. And we have to use that precious natural resource judiciously, scientifically, and responsively. That's the message, actually. I welcome once again you, sir. Thank you very much. Thank you.
Honorable Vice Chancellor, Professor Dr. S.P. Singh, sir, to kindly deliver his address.
Thank everyone present here. Welcome Professor Abhijit Mukherjee from IIT-Kharagpur. Very close to my heart because of my affiliation and association with Professor S.K. Dubey long time back, and then it was my family because my son studied there. So welcome to Royal Global University. We are very proud to have you amongst us, and I'm very sure that one of the most developing area in the country, Northeast is the new pivot for the whole east of the world, and Guwahati is going to be the center of the pivot, and that is the way Act East policy and Honorable Prime Minister of India and the government is foreseeing it, and I'm very sure, and they are in the right thinking, because the country and the world is moving towards east. The resources and the talent is also going from west to east, and India is a bridge between west to east. So you have done a lot of things in Canada, and you did your PhD from Kentucky, and I think you know the west very well, and I think the east is the new dawn, and I think I'm very sure that India can play a major role there. So this is on the broader side, but then if you talk about the topic, before that, by many esteemed colleagues of mine, Professor Alak Bora Gohai, Chairperson Academics, Dr. Ankur Ganguly, our Dean Academics, Professor Mipun, who is Dean Student Welfare and Dean of Earth and Environmental Science, faculty members from Botany, Geology, Geography, and maybe some other departments, Christy, who is from Social Work Department. I think social work students are also here right now. Social work students are here. Because I thought of talking something which is related to social work and groundwater. I just try to avoid the topic what Professor Mukherjee has chosen because he is the expert in that. But I will tell you my small 5 minutes or 4 minutes understanding of groundwater. For me, groundwater recharge is the requirement of the day. Groundwater is limited, everybody knows. But the recharge is also depleting. Recharge is happening very, very little. And the environment, people sitting out here, especially plastic, is the major culprit for that. The bottom of the ponds, the bottom of the rivers, bottom of all the water bodies are almost being covered by plastic. And that is the reason that the groundwater recharge is almost reduced to 40% in comparison to what used to happen around 50 or 100 years back when the plastic was not there. So plastic is one of the major reasons, and how I'm telling you is related to social work, because the awareness about reusing the plastic, and that is the World Earth Day we celebrated 2 days back, and the objective was reduce plastic by 50% by next. That plastic reduction by 50% will increase the recharge of the aquifer by 50%. So that is where my thought process is, and I think that is what is required. Other day I met Mr. Shende, who is a person taking care of net zero. Net zero also has something to talk about water, and in that our earlier Education Minister of India Javadekar ji has come. And I will share one thing very unique he discussed and said. People at times think when they have lot of resources, means once they are rich, they have a lot of resources at hand, they have 5 bathrooms and they have 10 wash basins and they have 20 taps, they think it is free and they can use it as they want. And you won't believe a Union Minister of India who was Education Minister once upon a time, he said, I brush my tooth by not opening the tap, but I take water in a mug. And I brush my teeth and I use water from the mug, a clean mug, so that it has been found while you brush your teeth and do gargles from the water from the tap, you waste 80% of it. And if you do it by using a mug, you save 80% of it. So, I mean, every one of you sitting here, I always say minimalistic approach, I will say prudent approach, and I will say if you want to save this world, if you want to save water, other than technology and policy, our role is the prime role. If we humans and people out here, and students especially, next generation, if you're not going to do and change your behavior, change your mindset, your children will not have water, I'm sure about it. So you have to be very careful. I'm not trying to make a fear sort of thing under you, but I'm telling you honestly, it is going to happen. We are a very rich country with respect to natural resources, but it doesn't mean that we are free to use as we want. And therefore, the groundwater, the surface water, the water divide, and geopolitics of water to policies of water, everything is the topic today. I'm very sure Professor Mukherjee will take care of those topics. And this topic is very close to my heart because I read geology and I'm very, very fond of groundwater geology. Todd, I used to remember like one page to the last page once upon a time. Still, I remember aquifers, aquifer conditions, and all that what is in geology. But then groundwater contamination, the recent thing which is happening in Deepor Beel, and also the leaching which is happening by putting the garbage of the whole city near to this place where we have IISST, and the leaching has contaminated the water, not only the Deepor Beel water, but also contaminated the groundwater of that area. This is very, very alarming. I think policies, procedures, and political will, along with our input of doing whatever little we can do, that is required. My best wishes to all of you. I have given 5 minutes, so I conclude. Thank you so much, Professor Mukherjee, for coming here and gracing the occasion. Thank you, everyone.
Thank you, sir. Ladies and gentlemen, we would now proceed for the talk by our very distinguished guest of the day, Shanti Swarup Bhatnagar Laureate, Professor Abhijit Mukherjee, sir, IIT-Kharagpur. Sir, allow me to introduce you to our audience. Professor Abhijit Mukherjee is presently associated as a professor in the Department of Geology and Geophysics and School of Environmental Science and Engineering, IIT-Kharagpur, and had also worked as a physical hydrogeologist in Alberta Geological Survey, Government of Alberta, Canada. Professor Mukherjee was Jackson School postdoctoral fellow for his postdoc in the University of Texas at Austin and have his PhD and MS from University of Kentucky. Professor Mukherjee also has a professional diploma in software engineering from NIT and has his graduate degrees from the University of Calcutta. He is actively involved in research and teaching throughout his career and has over 31 PhD scholars to his mention. With many publications, sponsored projects, Professor Mukherjee has many added feathers on his cap with the awards, recognitions, and fellowships. Mentioning a few fellowships: American Geophysical Union 2023, Royal Society of Chemistry UK 2020. Awards and recognitions like Shanti Swarup Bhatnagar Prize in Earth, Atmosphere, Ocean, and Planetary Sciences, CSIR Government of India 2020, that is the highest science award in India, AGUDL Memorial Medal 2023 by American Geophysical Union, Newton Bhabha Research Grant Award in Consortium NERC DST 2018, Jackson School Postdoctoral Fellowship at University of Texas at Austin 2006. He has also been offered Earth Institute Postdoctoral Fellowship at Columbia University 2006. So without taking much time, although it is a long list of achievements that you have, I would like to call upon the stage to deliver the talk. The stage is all yours, sir.
A very good morning to all of the dignitaries and guests. It's a distinct pleasure to be here today, and I'm really honored, with all the felicitations, and it's a very proud moment for me. So I'll be talking about a topic which has been already introduced. It's on the groundwater condition of India and what's the future and how we want to see through it. But before I go into it, I'd also tell you that my connection to Assam is not new. I've been working, and my students are working as I speak, in Assam, in Guwahati area, as well as Upper Assam, for the last 12 years. So I'm reasonably regularly visiting in this domain and working in various topics in the Assam Brahmaputra Basin. Very closely associated with IIT Guwahati at certain points, and several of our students are now faculty at Guwahati University. So without any further introduction, I'll just go directly to the topic. As Honorable Vice Chancellor said, that groundwater is something which is very pivotal, very important, not only to India but also to Assam, the Brahmaputra Basin. So I'll take that privilege and go further in. So maybe I'll just come a little this way. Am I still audible? Okay. So this is a topic that which kind of encapsulates the years of work that my students and I have, and my colleagues also, have been doing in various capacities. And what I'm going to present to you is just not one study, but it's a combination of studies. Definitely, I'll also highlight one specific study, which possibly would interest you in certain ways. So this presentation that I'm going to talk about is definitely about science, but it's also about policy interventions, and as the Vice Chancellor said, about the society. Okay, so this is where I think, personally I feel, that science needs to transgress in the future. Science, like we are all scientists here, we do our science, but how does it influence the society is the next big thing that we need to think about. So like I said, this is a combination of work that I have done with several of my collaborators and former students. So rather than going slide by slide acknowledging people, I thought I'll just put this one slide at the beginning talking about the various agencies that I have worked with. This is not exclusive. So there are many others, but these are the main institutes and organizations that I have worked upon, which ranges from the Government of India organizations, state organizations, to various institutes across the globe, including the British Geological Survey, NASA, the US Geological Survey, the World Bank, and so on. So let's come to the topic. Now, when we talk about groundwater, like the dignitaries who just spoken before me mentioned about the need of groundwater in our present society, and this is something that I think in the present times most of us are aware of. However, is this the first time that we are talking about groundwater? Possibly not. If we look at the history and mythology of India, which is a very ancient country with a very ancient historical records, you would see that time and again, groundwater has come in some form or other in the discussion of the narratives. The first photograph that I'm showing you is a motif that I photographed from the Jor Bangla temple in West Bengal, which is a terracotta motif, or UNESCO World Heritage Site, where it depicts the scene of the 13th day of the Battle of Kurukshetra. And it depicts the scene where Arjuna, the protagonist, is piercing the ground to bring out water to the ailing grandfather, Vishwa, lying on the arrowhead, telling you that even in the days of Mahabharata, the concept of groundwater was there. Now, it might be a mythology. I'm not going into the debate whether it's a history or mythology. However, the concept was there. Even the author of Mahabharata knew about it. It's a matter of fact that when I visited Kurukshetra a few years back, I did see the place where the potential arrow was put, and the water is still coming out, actually. There is a very, very intricate physical reason for that to happen. So that's a different story. But anyway, if I now look at the documented history of India, from the very ancient times that we know about, the Indus Valley Civilization, now also called the Saraswati Valley Civilization, to the present times, you would have enough occasions, opportunities where groundwater has been mentioned. So much so, the town of Mohenjo-daro is known as the city of wells. More than 800 dug wells has been identified, discovered, excavated from Mohenjo-daro. I was visiting Harappa, the general area of Harappa, about a month back, and I was amazed the water structure and the water management structures that was present in the Harappan civilization. So from the very early part of the Indian civilization, groundwater was known. And that has been the case as it moved through the history, and there are so many examples, the groundwater structures are present. However, it's also a matter of fact that although it has been an essence of life, of society, it has not been really highlighted. So let's fast forward and come to modern India. Now, we are in the 21st century, right? Looking toward the 22nd century. And so I'll go back and forth with South Asia and India broadly, but it is pretty much the same thing. And you would see that it's a collage of photographs which varies from, the domestic uses for drinking water, from industrial usage, from, for other bathing uses and development of urban structures, industry, business, and so on. But more importantly, here, food production. Like when we talk about water, we have a common notion, very generic notion, that water is for domestic purposes, some industrial purposes. What we fail to understand is that the main purpose of water, specifically groundwater, because 95% of the fresh water that is used in India and across the world is actually groundwater, actually goes in food production. So if you look at this pie chart, which is a bit old, but I think the statistics is by and large the same, 85%, a whopping 85% of the groundwater usage is actually for food production. So when we are talking about water, actually we are not talking about drinking water as much. Part of drinking water is there, but it is actually the food production that is the main thing. So the food security and the water security goes hand in hand, which most people don't realize. So if you don't have water, you don't have food, okay? And as we work, as I work as a specialist in this field, our job is to make sure that our administration, our highest authority, knows about the facts. So let's talk about briefly on the groundwater issues. Okay, so groundwater is important, so what? Why should we be worrying about? Well, the summary is reeling through, and as you know about, I don't know how much of this you see in the Assam area, possibly not much, but if you go to a little bit west from here, to the western states, this is a very common story. And I'm sure like you see this in the media, maybe on your own, in the villages, as we are passing through the summer. Getting the sufficient volume of water for either irrigation or, cultivation or drinking water becomes a luxury. But at the same time, you have water excess, right? And this water excess, common notion is water excess, also, you can think it as flood, waterlogging, and so on. It's something, a phenomena that is mostly related to climatic disturbances. However, the reality is, the science is, it's actually the groundwater which modulates the floods. Okay? Groundwater has a big say whether flood is going to happen or not. The irony is, let's speak about today, 24th of April. We have, the water scarcity issues in several parts of western parts of India. In the next adjoining country, geographically separated out, but geologically it's the same formations. In Pakistan, just in the last 3 days, 87 people have died out of flood. Okay? So just think about it, like few hundred kilometers this way and that way, you are either dealing through water scarcity or you are just swamped, dumped with excess water. So it's also a management issue, and this is where the beauty of groundwater is that it is just not science, just not policy, but it's also management and the society. Either way, for the common people, it eventually translates to the drinking water security issues. Because, we can possibly still be alive without having food for a couple of days. We cannot do that with water, right? We need to have water, drinkable water, for our sustenance as a human being or any other known creature that, at least on the land. I don't know if fishes drink water or not, but on the land, we need water. Sorry. But is it the case that if you have water, you are safe? Possibly not. And if you are drinking bad water, you end up having pretty damaging health issues. Okay? These are photographs that I have not taken from Google. I've shot it myself from the people of this state, adjoining states, where people just had bad water to drink. It's nothing that they have done in your previous life, no sin they have done. I mean, not that I know of. It's just that in this life, they have been drinking bad water related to the groundwater, drinking poisons like arsenic, like uranium, which eventually gets into your body and creates a lot of health issues. So this is something that is just not science, just not something to talk about in conferences. It is also about something in your daily life. It's a glass of water that you drink. And that's where the importance is. And let's talk about the white elephant in the room, climate change. Now, I would not call myself a climate change expert yet, maybe someday in the future. As of now, I have talked to the best in the world. I have a strong feeling that most of us, none of us, actually understand what climate change is. I mean, we have a general understanding, a lot of arm waving, but what exactly climate change is and how it's going to affect us, what is the impact of it, we don't know. Well, possibly only the future can tell. But we do know that if climate change is happening, would be happening, the hydrological cycle, that is water in general, groundwater for sure, is going to get affected. So by and large, all these photographs that I showed you in the background are actually not going to get better, but getting worse. So it's the time that we brace in our states for an impact to come, okay? And that's where the importance of this knowledge is. And this cannot be more true unless we are in 2024, 6 years away from the year 2030. What is big deal about 2030? Well, as some of you might be knowing, many of you, at least in the teaching, you'd know that the year 2030 marks the deadline for achieving the Sustainable Development Goals, the UN Sustainable Development Goals, the 17 goals that the UN declared initially in the year 2000 and then in the year 2015 to be achieved by 2030, the 17 grand goals that ties up all countries, all nations, irrespective of caste, creed, religion, and nationality, where we should achieve these grand goals, including zero poverty, reduce hunger, safe access to water across the planet. Okay? Of this, goal number 6 is explicitly on accessing to clean water and sanitation. Now, if you look more carefully, all the other 16 goals are also connected to water in some way or other. But explicitly, SDG number 6 is on water. So you cannot highlight anything more than this. And we, as human beings, as the resident of this country, one of the not one of the most populated country in the world, we have a big responsibility. So, why we are studying about groundwater? Well, so in the last about 20 years, more precisely 15 years, groundwater has taken the center stage. From a person in the common person in the road to the Prime Minister, they are all talking about groundwater in some form or other. So what happened? Well, in 2009, there are a couple of papers that got published, one from NASA, one from NGRI, which talked about the depleting groundwater. Before that, yes, we knew by and large, but we didn't have a clear picture. It is only when a couple of papers integrating some global data sets came up where we realized that something big is happening, something really big is happening. And since then, in Indian media as well as global media, a lot of hue and cry has happened that India is going to be the test scenario for the world, where India has a drought in the underground. It's not above the ground, it's there, we already know, but it's also going to be a drought in the subsurface. So in the last about, give and take 20 years, more efficiently in the last 15 years, my collaborators, my students and I have been working on a very simple question. The simple question is, how much safe groundwater is available in South Asia, specifically India, and what is the future? Very simple question, but I think there is a lot to say. And I would definitely like to highlight the word safe here, because that's also extremely important, just not having the volume, but also the quality, the chemistry. So that brings us to the question, is this an emergency? Do we need to really rely on South Asian groundwater? What is the big deal about it? Well, just like the Dean told you at the very beginning, India, or the Indian subcontinent, which is India and the 6 sisterly nations, we occupy about 3 to 4% of the global terrestrial land, only 3%. Whereas we host about 1/3, like about 30%. Thank you. About 30% of the global population, possibly much more now, and the crop production, the food production. Now, you are students from different backgrounds, I definitely understand. But even for a kindergarten kid, it will be very obvious that 3% of the land cannot sustain 1/3 of the humanity in this general area, right? It's not possible. It's not sustainable for sure. So you don't have to do any math for this. So definitely there is something big. And what is the cause of it? Well, you look at the global population map, you have 2 places which are really kind of very brown. Of course, China is there, and then there is India. Now, if you look at the crop production, again, India kind of tops, right? So definitely, there is this human angle and the food angle to the water. So let's look at a plot that was published by my good friend Richard Taylor in 2014, about 10 years back. What it shows you are the 6-7, highest consumer of groundwater, 6-7 nations which are highest consumer of groundwater. And what you would be pretty excited to see, India is the leader. It was the leader, it still is the leader, and would be the leader in future. Okay? At least in this one domain, we top. Okay? We are the best country in the world. So matter of fact is that if you take the second one, the second best, USA and China, you add them up, India is still the leader. Okay? So India has been using a lot of groundwater, in the last about 60 years now, yeah. And the question is, so is it all of India? Well, let's look at this other map. So this is, what is called the irrigated irrigated cultivation through groundwater in this planet. And this color shows the concentration of the irrigation plants. You would see that this deep maroon to scarlet color is only present consistently in one area. And that one area is continuing from, Pakistan to Bangladesh here, little bit on the stretch of Myanmar, passing through the northern part of India, the eastern part, and northeastern part. So if you look at this map, which is kind of more highlighted on, you would see that within this area, sorry, there are also pockets. So what is this area? You can broadly call it the North Indian Plains, but I have a better name for it. It is called the Indus-Ganges-Brahmaputra Basin. Okay, the three mega rivers of this planet, the Indus, the Ganges, the Brahmaputra, and possibly also Meghna for Bangladesh. So this Indus-Ganges-Brahmaputra Basin is also the area where you have a lot of groundwater abstraction. Consequently, in the present day, India is the largest user of groundwater, not today, in human history. So nowhere in the past, and possibly not in the future, any other nation would be using as much groundwater that we are using today. Okay? So it's a historical time of revelation that we are using a resource, just take it as a resource, in a quantity, in a rate that has never happened in the past. So this is something that we need to understand. Now, that's too much of a sales talk. But what is the science behind it? Well, if you look at these two maps, the left one is what we call the broad hydrogeological map of India. Okay? Now, if you look at the government maps, they are too intricate. You get lost in the details. So it is a kind of simplified version of that. You would see that there are two areas, two colors rather, which are more prominent. One is the light blue color out here, and then there is a deep blue color out here. So they kind of constitute about 80% of all the colors. This light blue color, if you can read from there, it's called the Indus, the Ganges, and the Brahmaputra Basin. And this Indus, the Ganges, and the Brahmaputra Basin, if you take the terrestrial land cover, it constitutes about 23% of the land cover of Indian subcontinent, only 23%. But it hosts more than 70% of the groundwater reserve of the subcontinent. So yes, in the terrestrial land distribution, they are not that much. However, if you take it in the terms of the resource, they are, they are extremely rich. How rich? The Indus-Ganges-Brahmaputra Basin, or we also call them the IGB, is regarded as one of the most prolific groundwater system in the world. Okay? There are 2-3 more, but IGB is definitely one of the best. But then you also have this other color, the deep blue color, which, as you can imagine, it constitutes about 60% or more of the Indian landmass. Ironically, only 20% of the groundwater reserve is in this 60% of the landmass. So there is no wonder that the city of Bangalore is dying out. And then there will be many others in the future times, unless we really take cognizance of this. So the IGB is definitely something that we all know about. I'm standing on IGB, part of IGB, now as I speak. It is also, like I said, it's one of the most prolific groundwater system in the world, but it is also the most stressed, human-stressed groundwater system in the world. It is the most abstracted one, right? So the IGB has a lot of story to tell. Now, if you look at the map on the right, you'd see the same geographic distribution, but this time we are looking at pollutions from a chemical side. This was the physical end. Now we are looking at the chemistry. And what you see are this blue color, which indicates arsenic, the yellow color, which includes fluoride, and then you have salinity. Arsenic and fluoride are regarded as the two most widespread pollutant or contaminant in this planet. Okay? And that includes your Brahmaputra Basin out here. So we are somewhere just here. So just in the arsenic belt. Okay? We also have fluoride here, if you are not aware of. So like I said, like for the last 12 years, my students and I have been working broadly in this Brahmaputra Basin, trying to understand where all this arsenic and fluoride are coming from. Okay? It has a strong geologic background to it. We'll talk about that in a minute. So the point in this map is that, okay, IGB has a lot of water. It is abstracted a lot for food production, but also it is highly polluted. Much of it is polluted. So the net groundwater availability in the IGB is actually much limited than what it looks like from a raw quantity calculation. And this relates to, pretty deep physical and chemical sciences. I'm not going to explain all the details of it. I'll just broadly tell you that if you need to understand the groundwater system, you need to understand it through the processes. So the process starts with the interaction of the subsurface with the surface water, namely the climatic water, which is, mostly rainfall, precipitation, snow, and so on. And this water, sorry, as it seeps in the subsurface, they go to react with the rocks, with the sediments. It's happening below your feet, okay, as we speak. And it can take from few days to possibly millions of years, few millions of years, for this water to pass through, okay? Again, there is a scalability issue on this. So there are flow systems through which the water is flowing through, can take millions of years. I can tell you there are groundwater which are getting recharged in the Shivalik front, north of here, about, 100, 120 kilometers north of here. These water coming to Brahmaputra takes, we did some dating recently. They came almost like more than 30,000 years or something, okay? So when we are looking at this bottle of water, assuming this is groundwater, it has an age. It is not recharged yesterday. It's fossil. I was shown fossils few minutes back. These are fossils as well. If you date this water, assuming this is groundwater, you'd come with an age of 25 to 30,000 years. Okay? So this resource has accumulated in the subsurface in a geologic history, not yesterday. So when you're taking out this resource, even in this bottle of water, we are actually taking out the geologic history out of the ground. Okay? And then we have discharge. So this groundwater passes through, following several physical laws, okay, laws of continuity, and eventually discharges. So if you go to Brahmaputra, which is just next door from here, you talk about all these bills, right? You go to Majuli, you have all these wetlands. What are these wetlands? These are discharge zones, where the groundwater that is recharged in the Shivaliks and the Himalayas, they eventually flows out, in a large surface water body. Eventually, all of them discharging to the ocean, okay, in the Bay of Bengal or the Arabian Sea for India. Now, these are the natural phenomena. This is happening. This started with the formation of the hydrological cycle, possibly 3 billion years back, and it has been continuing. We have nothing to do with it. It's a natural process. But we do have something to do with it. Because in the 21st century, starting another 200 years back, we have been messing up with this natural system. In 2022, 1 year back, 1.5 years back now, the US Geological Survey, which is regarded as the pioneering geoscience organization in the world, they published a new hydrological cycle, okay? And in this new hydrological cycle, now, in addition to geological and physical chemical phenomena, they have also added human in the picture. So in today's time, if we are talking about something of a resource of this magnitude, we cannot leave out the human out of the picture. Human is integral part of this system. So climate change, when I say climate change, is human-induced climate change. Human practices and policy interventions do modify these processes to a large way. So let's talk about the recharge, and let's look at how the recharge has been happening in India. So I am showing you the work of one of my former students, where we delineated the recharge in the Indian subcontinent for the last 20 years, from 1996 to 2015. What you do see that there are variations in color, green being high recharge, red being low recharge. North Indian plains are mostly green, southern Indians are mostly red. However, you see that there are also variations. So there are interannual variations. But broadly, there are, a broad pattern, but there are variations which indicates that recharge is not constant. From year to year, it varies on various factors. It's just not the rainfall, but that's something to think about. But this water, when it enters the subsurface, it goes through the most complicated chemical reactions. I just saw the chemical lab. The experiments that you do in these labs also happens in nature. Okay? So nature is our lab. And these same reactions, quite complicated, both organic and inorganic, takes place in the subsurface, bringing out, ions, minerals, as well as the contaminants. So the natural reactions that you see in the subsurface are also the cause for the liberation of the contaminants like arsenic and fluoride. Okay? And the human policies. So yes, arsenic, I'm sure like in Guwahati you would be aware of arsenic, and I am 100% with you that it's a natural phenomena, but we also understand in present times that whatever the original pollution was, it got aggravated by human interventions. So it's the human which actually made it worse than better. And through our study in West Bengal, which is regarded as the experimental site for arsenic studies in the world, we have found that over the years, arsenic enrichment has increased, and possibly the reason is human. So I present to you the first map of arsenic pollution in this country, possibly also in the world, which is kind of linked to the geology and the human practices that has been happening. What you do see that we integrated about 3 million data from working with the Jal Jeevan Mission, where I'm an advisor, and eventually ending up with this map which tells you the risk, the number of people that are possibly under threat. Now, this 90 million is a conservative number. Actual number is around 200 million. Okay? These are the number of people who are actually exposed to the threat of arsenic, drinking arsenic as we speak. And you see that this belt, this main belt, is ranging from, Punjab, Haryana, from Pakistan, through the Ganges Plain, mostly the eastern part of Ganges Plain, in the West Bengal region. Bangladesh is also continued here, going to Assam. Okay? In the Brahmaputra Basin, Assam and its sister states. So it's a natural phenomenon. As a geologist, I'm sure like there are a few geologists in the audience, you would immediately see that it is a Himalayan foreland. So definitely the geology, the tectonics has a huge role to play with it. So I'm working on a hypothesis now on a global scale where I'm demonstrating that tectonics is actually the cause of all this groundwater pollution. But what we also would like to see that there are two other zones. One is in here and the other one in here, which are also having some level of arsenic. This is the Narmada Basin here. From a tectonic side, it's called the Central India Tectonic Zone. And these are the gold fields in Karnataka. Okay? So the arsenic contamination in a very spatial scale, large spatial scale, is definitely geologically controlled. But like I told you, if you look at a micro scale, you would see that the human has made it worse. But that's not all. That's the natural pollution. Let's talk about the human source pollution now. Your Honorable Vice Chancellor talked about the plastics. We also have other pollutions. So I show you the data from one of our more recent studies on pesticides and other organic pollutants from the Ganga Basin on a regional scale. So my students kind of identified that there are about 19 different organic poisons, I would use poison, that are found in natural water systems of the river Ganga as well as in the groundwater. So as we are drinking, and we are not aware of it, arsenic we are still aware of it last 30 years. This organic pollution, we don't know, okay? There is no really good treatment even, like all these fancy filters that we have in our home cannot take care of our organic pollution, just to make you assured of that, okay? So this organic pollution is all across us. I would not be surprised if this is a similar story also in the Brahmaputra Basin. And something we really don't talk about. Well, arsenic we talk, nowadays we're also talking about the pesticides. What we don't talk about is the fecal bowel pollution related health issues. Now there are all kind of medical students here, right? Or medical related students. You know that almost 80% of the communicable diseases are actually related to either air or water. Water, if you have arsenic, pesticides, you are going to get sick, not today, not tomorrow, maybe in 10 years. If you drink fecal coliform, you are going to sick in a couple of hours. So most of our enteric diseases, including typhoid, diarrhea, and so on, cholera, they actually kind of gets triggered by these, enteric viruses and bacteria. And where are they coming from? Well, to say the least, they are coming from us, like we are the producer of those. So through the human practices, specifically defecation practices that we have been practicing in this country for last several hundred centuries, we have actually polluted the groundwater. Now, the government of India do realize this. It's not something that I'm saying you covered. They know about it. It's not very highlighted. They know about it. And over the years, they have tried to make it better. Not starting in 2014, honestly. It started in 1991 when they started developing structures. But definitely in 2014, it got accelerated in terms of the Swachh Bharat Abhiyan. And one of the main reason for building these sanitation structures, yes, it looks good, but it also actually cleans the water, ideally. There are some caveats. Let's not talk about that now. So yes, the sanitation measures possibly showing initial results in benefiting the water quality. So let's talk about, so this is more a very generic overview, although they are based on our studies, but not any specific study. So let's tell you very focusedly, like some of the things that we are doing. So at the very beginning, I told you that I work both on the physics and the chemistry, nowadays also society and biology of water. Professor Ganguly is very excited to hear biology. Yes, I do a little bit because some of my students are from biology background. To look at how the groundwater and also the surface water is evolving. And I don't restrict my students into any specific technology. It's applied science, and I feel because it's a tertiary science, you need to apply whatever technology is available, whatever works. So as you would see, that we use very traditional geologic exploration to deep exploration, deep drilling. We use the most modern earth observation and remote sensing. We use geophysics quite a lot, piezometry, hydrogeochemistry, river pollution studies, hydrology, and not the least, data science, big data analytics. So what we have done over the last about 20 years, that we have done this extensive, intensive field work, okay? Quite intensive. Even as, we speak about the summer drilling in, my students are working on the plains of North India collecting data as I stand here, okay? So, yeah, we are trained to work in harsh weather. We're not worried about it. But all this data that we are collecting are not constrained in a small limited study. Rather, we want to spread it out into a map of a big picture. So what we have done over the years, in the last about 10 years, we have developed these protocols, working with the computer scientists in our institute. We have developed global scale protocols on using this data in AI platforms. Now, in the last 3 years, people are talking about AI. My student, who is possibly the first student using AI for groundwater studies in the world, possibly, he joined me in 2013. He graduated in 2019, now a faculty at Jadavpur University, okay? So we were at least 10 years ahead of the boom, so-called boom, because AI is not new. I was trained in AI when I was even in the colleges, okay, 20 years back. So AI is not new. It's just, all these hooplas. But anyway, AI do have some interesting, intricacies, and you can use AI to, do something really good, just not fake images and so on. So we have been using AI to integrate all these, data in 3-dimension and 4-dimension, and read the pattern to get some real good picture out of it. So let's talk about this one specific study where it reasonably got a lot of highlights. More importantly, it did influence the policy of this nation in quite a big way. So let's talk about the quantification of groundwater in India, one of them. So I have been working quite closely with NASA for the last about 14 years. The head of NASA Art and Biology is actually the director of Art and Biology is my good friend Matt Rudel, who was also the PI of this project. It's called the GRACE mission. As it says, Gravity Recovery and Climate Experiment. The mission that was started in 2002 by NASA, European Space Agency, and the University of Texas at Austin. So when I was working at the Texas Austin, my supervisor was one of the PI of that project. So I got exposed to the project back then, 2006, almost 20 years now. Yeah. And the idea was that the satellites were shot out, two satellites, which are still kind of rotating above us 15 times a day at an elevation of 500 kilometers, at a distance of 220 kilometers, connected by a laser beam, okay, micro laser beam. They're nicknamed as Tom and Jerry, very unique. So the idea is, which one is first, like Jerry or Tom? Tom. Tom is at the back. So Tom is here, and Jerry is there. So Jerry is running, Tom is trying to catch it up. What is the idea? Well, it goes by the basic principles of physics and geology. So these two satellites are actually what we call, in geological term, gravimeters. They are measuring the gravity of the planet. As they are passing through one point in space, they are measuring the gravity of a chunk of a surface of the Earth. Now, if you are from the physics background and you're thinking, Earth's gravity is 1, like this is just one constant value. Now, that is a lie. That is not actually the case. Actually, Earth's gravity changes between you and me, like where you're standing. So every pixel on Earth's surface has a different gravity, if you can measure. What these two satellites have been doing, they are passing, around Earth and measuring the gravity of a pixel of land, which is 400 square kilometer. That's the minimum resolution that it could see those days. And the idea is that as, Jerry passes and it measures the gravity, Tom comes, measures the gravity again. And if it sees there is a change in the gravity, in a nanogals, very little change, it's possibly can be attributed to the change in groundwater systems. Why? Well, the philosophy is that unless you have a catastrophe, like a tsunami or like a huge earthquake or something, which has really changed the Earth's internal processing, the change of the Earth's gravity in a very small, package of time is possibly related to the change in the hydrological mass transfer. It's physics. And if you know that, so that's called the terrestrial water storage. You can do a little bit of math, not a little bit, quite a bit actually. So, all these parameters that you are seeing, which is soil moisture, surface runoff, snow cover, you cannot compute them yourself. You have to go into the NASA supercomputing system and do those. So NASA supercomputers are constantly, spitting out this data. One of my former students, who is also a primary author of this paper, is now manning that supercomputer in the Oak Ridge National Lab in the US. So if you know those values, you subtract them from the terrestrial water storage, you end up with what we call the groundwater storage change. The word change here is very important. That's the delta here. Okay? It never measures the absolute value. It always measures the change. Change from when Jerry went out and Tom came in. Okay? So it doesn't give you an absolute value. So for the last 22 years now, there has been fascinating data that has been spitted out through this mission. Originally, it was planned for 5 years. In 2018, the second generation GRACE satellites went in, and it's still going on. So in 22 years, it has really opened our eyes in terms of both, hydrological studies, but also climate change studies. They are the primary source of data of all the climate change that you are hearing about, including the polar ice cap melting. Okay? It's not visual, it's more gravity-based data. But then, data are data. Okay? They are all remote sensing data, Earth observation data. Do they really mean anything? How do you know? So you have to look at the ground. You have to go to field work, right? You cannot avoid that. Yeah? So in my capacity of working with this Central Groundwater Board, which I understand next door, and I was one of their 5 experts advisor for quite some time, I did work with them in collaboration. We went to field, collected data from almost 20,000 locations, and we calibrated the satellite data, satellite-borne data, with the ground data. And we found that there is a reasonable match of 0.6 to 0.8, which is a reasonably good match for a data of this scale and this sort. So we're pleasantly pleased that the satellite data, which is in a much higher resolution in some way, higher temporal resolution than the ground data, is good enough to do some analysis. Because yes, if you look at the CCWB data, that's a point data rather than a chunk of data than the satellites are capturing. But CCWB measures it only 4 times a year, whereas the GRACE mission is going around every day, right? So the scalability of time is much higher in terms of the GRACE mission. So here I'm showing you the point data. This is the bidecadal groundwater level trends across India. What you do see, there are trends which are saying increase of groundwater level. There are trends which are saying decrease of water level. What you would be interested to see that there are a lot of yellows here. Okay, these, which means groundwater level is receding in the Brahmaputra basin. Although there are some increases too, but overall this is the trend, and I'll come to this trend in a few minutes. So I show you the decadal groundwater storage change in India. It's a little older data, but I think it still tells the story. So you see, like from 2003 to 2014, there are changes in color. Now, just looking at it, you'll be lost in the color, right? So let me tell you what the colors are. So the blue is good. Okay, don't go into the details of it. Blue is good. You have more groundwater. Red is bad, less groundwater. So if you are transitioning between these colors, you are actually looking at the scenario of groundwater storage change. So this map, again, you will get lost. So let's show an animation. And you see the colors are changing. The colors are changing broadly. No one place is stagnant, right? Every year they are changing. Okay? So you did now see that the colors were changing. So, of course, you can conclude that, okay, fine, groundwater is changing by and large every year. Okay, so what's the big deal? Well, the big deal is that if you had looked more closely, you would have seen that the North Indian plain, the Indus Ganges Brahmaputra basin, which was blue in 2002, 2003, is now red. Okay? Consistently red over the years. So you actually has lost a huge volume of groundwater. I'll tell you the quantity in a minute from the North Indian plains, okay, Indus Ganges Brahmaputra basin. Whereas, contrary to what people think, there is actually groundwater rise in some of the parts of central and western India, okay? Which is a pretty surprising thing, and I'll come to that in a minute. People were not talking about it. Now, if those colors were kind of getting you lost, so let's do some trend analysis. So these are linear and nonlinear trend analysis of 5 hydrometeorologic regions of India. That's North India, West, Central, East, and South, based on when the monsoon is arriving. Okay, they are not just geographical parcel, but it's based on the hydrometeorology, the climatic patterns. What you do see, and this is inter-India, right? What you do see that inter-India region, there is a slight decline of the groundwater reserve, slight. Again, what is slight is very relative. But if you look at northern and eastern India includes northeast India, those are very sharp trends. General idea is that North India is drying, Punjab, Haryana, we all talk about it. Eastern India has a lot of water, historically water affluent, it's all good. Now, this is not you saying, even the ministers told me that, okay? the matter of fact is, if you look at this trend, actually you have a much higher rate of depletion than North India in the eastern parts of India. And you'd be surprised to hear that people all the time, even today, the policymakers talk about that, okay, Punjab, Haryana are getting really dry, they are losing a lot of groundwater. Matter of fact is, this place where you are sitting now actually has the highest rate of groundwater decline as I speak today. Okay? Policymakers don't want to look at it. They try to stay blind. Matter of fact is, in the last 15 years, Assam and the Brahmaputra basin in general has lost more groundwater than many other parts of the country. Okay? So if I take out all the noises, these are the blue color and the red color. Blue meaning places where groundwater has increased, red is where groundwater has decreased. Okay? So that's helpful for a policymaking point of view. So let's look at the groundwater drought, including in the northeast India. So what are the triggers? Well, we do know that one of the main consumer of groundwater is actually the crop production, right? And it didn't start yesterday. It actually started at the Green Revolution. Okay? The Green Revolution that started in the 1970s, which made our country from a food deficient to food efficient, came with a cost, the cost of groundwater. Okay? It took out the resource that we don't get to see. So with the introduction of water-intense high-yielding crops, you need flood irrigation. Or I would not say you need. The agricultural farmer, they think we need. Now, whether we need or not, that's a big controversy, actually. And extensive flood irrigation at the cost of groundwater has led to all this crop production, which made us food rich. And also, as soon as you get affluent, you take the next step. You now transform many of your crop to cash crop. It's happening all across the country, specifically in Western UP, Haryana, Punjab, those areas. You now try to produce even more cash yielding crops, which are also more water intensive. Consequently, huge amount of groundwater exploitation has happened in India in the last almost 50 years now. Okay? So it's not a one-day story. Now, people talk about climate change? I'm not discarding it. Okay? Climate change might have a say on this. However, I have a strong doubt that the data I showed you, which is about 15 years, can really pick up climate change signal. Maybe it's embedded, but can you decisively say that? Possibly not. At least I cannot. Okay? There might be trends, but that we don't see yet. So it is mostly human-induced. Now, if that was sin, something that I would like to make you aware of, which you possibly have not seen, is that, and this is a study specific to Ganga, I can assure you it's also happening in Brahmaputra, it's also happening in the Indus. We think that these rivers are mostly glacial fed, which is really a myth. Okay? Yes. So in the higher reaches, up in the hills, yes, they are glacial fed. But as these mega rivers transitions to the plain land, they are actually 60 to 80% groundwater fed. So it's a simple mass balance. Okay? If you take out the left-hand side of the equation, the right-hand side has to decline. No question asked. So these rivers, which are getting sustained by groundwater, if you take out the groundwater, the river water has to go down. So what I'm showing you is just not mathematical calculation, but I'm showing you a photograph to substantiate it. These are Eastern UP, Bihar, West Bengal. That's the Ganga in the summer times. I was told, and I have seen myself, upper reaches of Brahmaputra also has the same fate. There are kilometers after kilometers, sandbar has started forming. Why? Because you're taking out the groundwater. Okay? So this is not a calamity that is only related to something that you don't get to see. It's also killing your rivers. So definitely, the questions are pretty obvious. That is the Ganga drying. Should be the case of Indus and Brahmaputra and all other big rivers of the country. Now, just for Ganga, if Ganga is drying, it is going to stall the food security and achieve the SDGs. By 2050, by 2050, more than 100 million people are going to go through extreme to, like severe to extreme food crisis. So this is not just something, a science that you do in your science project and just keep it in your backyard. It is going to hit you hard, really hard. But then I'm not trying to scare you here, right? So that's not my role here. You invited me, so I should not scare you. So I also try to give you some happy pictures. And the happy picture is, just like we have this drought happening, you also do have places in India where groundwater is replenishing. Now, this is not something that was very obvious to the common people or the government until we published this data. And let's look at that map again that I showed you earlier. Now, this time it's only the areas where you have groundwater level increase, okay? Not decrease, decrease and increase. So this is 20 years of data where we have groundwater level increase. And what we can see is broadly across the country, there are places where groundwater increase has been observed. However, because of the dispersed nature of this data, we are not very sure where exactly. But then if you look at two examples, one in Gujarat, one in Telangana, Andhra Pradesh, more Andhra Pradesh, undivided Andhra Pradesh, you'd see that the same signature is also available in both the GRACE data and the ground data, telling you that at least in these two areas, and actually in some other areas also, groundwater rejuvenation has happened. Okay? It has happened. Now, if you're taking out all this groundwater, then where is the water coming back? Right? What we learned is that over the years, there are policy interventions. Now, there is something to be said about this. These policy interventions, yes, in some states, they are very vocal on rainwater harvesting, artificial recharge. In some other states, they go for, rejuvenating riverbeds, recharge canals, and so on. But these were, to my understanding, very little and less integrated plans. They were not, yes, they would do some good, but not in a country scale. Now, what we realized is that there are a couple of plans which actually had unintended outcomes. And that's something I should highlight here. The first one, the first one is not really shown here. The first one is a scheme that is run under the government of India. It's the largest social scheme in this country called Manrega, Mahatma Gandhi Rural Employment Scheme, right? You also you possibly would know this as 100 days work, right? It was started about 20 years back now, and it is running reasonably successfully, to my understanding. Now, when this plan was floated, this mission was floated, the main idea was to give employment to the unskilled laborers in the villages, because they cannot get a skilled job, so they do have something, at least 100 days of work in the year. Now, if you are in the local administration, what are you going to do with all these unskilled laborers? What you would do is, you would ask these guys, go and do something, okay? Show something that you have done, and you will get the pay. Now, what is that something that they would do? Well, I think we all understand digging a pond would be a good thing to do, okay, if you have the land, of course. So, across the country, this philosophy was practiced. Why pond? Well, pond does a couple of things. Pond gives you, a body of water, which is always good. It also acts as a, like a rainwater harvesting structure, which you can use in the dry times. And it also acts as a local employment option, because you can have fisheries, right? So it was all a win-win thing. Now, what they did not know, or possibly at least intended, that these ponds across the country became the groundwater recharge structures. Unintended. They were not planned. Okay? And I didn't say that they are not planned. This the Secretary of Rural Development told me in person. Yes, they are not planned. So in 2017, when we published this work, the government was in a double mind whether to keep the mission or not keep the mission. Stop Manrega basically. But then this work showed that if not anything else, at least the groundwater resource of India has got benefited out of it. So in 2018, the total allocation of budget doubled. 75% of that was earmarked for groundwater rejuvenation. And this is also the trigger of the Jal Shakti mission. Okay, you heard about it? So the Jal Shakti mission actually started from this slide I'm showing you. Okay? One other mission that I should talk about, again, that was possibly unintended. This is called the Jyotigram project in Gujarat. The Jyotigram project started in 2002, 2003. Now, I don't know the case of Assam, but in West Bengal, if you have to use electricity for food production, there is a cost for it. But many of the western states, they have free electricity, for agricultural field. Now, in Gujarat, which is a historically dry state, that is the same thing that used to happen. And over the years, farmers in Gujarat, even being a dry state, they have been running the pumps 24 hours a day. Consequently, the groundwater is falling. The government was aware of this. So in 2002, 2003, when the present Prime Minister was the Chief Minister of the state, his government initiated this project called the Jyotigram project. What happened in Jyotigram project? Well, they split the main electric feeder into two feeds. One feed going to the households with a 24 hours electricity, and another feed for the agricultural field with 8 hours electricity. So the electricity was rationed to 1/3. What happened? Well, this is a pretty complicated plot, so I'll just walk you through it. So this red line is the observed groundwater trends between 1996 and 2014-15 when we did the study. What you see that the groundwater level came down up to 2002-2003 when the Jyotigram project was incepted. And after that, maybe because of many other things, but definitely from the Jyotigram project, the lack of groundwater abstraction, I mean, they are still surviving with 8 hours a day of electricity. So why use it for 24 hours? So they did a smart thing, and the groundwater reserve started coming up. So definitely there is a lot of mathematics, a lot of physics behind it. I'm not going into that. But what it did show that a policy, maybe intended, maybe unintended, can make a difference. And what I would like to conclude with is that there are, just like we have very negative scenarios, like here in the bars, you also do have positive scenarios. So at present, the north is losing about 8.5 cubic kilometers. The east is losing at about 5 kilometers. So if you take together, that's about 13 cubic kilometers of groundwater that we are taking out every year, of which cumulatively about 3 cubic kilometers of groundwater is coming back. So if you do the math, simple math, irrespective of the space, India is losing about 10 cubic kilometers of groundwater every year. Now, 10 is just not the number. It's the cubic kilometer that you should be worried about. That's a huge volume that possibly we cannot even imagine about. That's the volume of groundwater India is losing every year. Okay? So that's why the trend was a bit negative, which definitely would become more negative in the years to come. So this work, like I said, it got a lot of highlights, including it became the website image of NASA for a day, okay? Because it was a work in collaboration with NASA, so they highlighted, how the India's groundwater gain has happened, and we are quite pleased with that. And it was covered by most of the media, across India as well as across the world. Much of these are, in my recent book that came out as Global Groundwater. I'd be happy to share a PDF at least with you if you are interested. I have just one copy. You are welcome to buy also if you want. But I'll end that with a thanks, and we'll be happy to take any questions that you might have.
Good afternoon, sir. My name is Navijita Chakravarti. So, sir, as a future geologist, what are the measures or steps that we can take for this groundwater depletion that is happening all over India? So, what are the steps that we can take to prevent it?
Okay. Well, it's a human problem, right? It's of course a natural problem, but it's more a human problem. So we human have to solve it. To do that, the first thing that I would do if I was a policymaker is to understand the science, because you cannot keep the science on the back and say like we're doing good things. So you have to first understand, like I was trying to walk you steps by step, what is happening and where is it happening. Now, with all this data and all the other work that have been done by very experienced people across the country, we now do have a reasonable understanding of how the science works. And the way the science works is that water on the surface of Earth, including surface water and groundwater, we call them one water. We have this notion that rivers are separate, groundwater are separate, lakes are separate. That is actually not the case. They are all connected, and we have this concept coming up of one water. Now, population is going to grow, food demand is going to grow. There is no question asked. That's the future. Now, how do you buffer it? Well, the way you can buffer it is to go for something called a conjunctive use of water. Conjunctive use of this one water. So don't go for a blanket policy. Tailor the policy to the place, to the region, to the society. Okay, human is a very important factor here, because the reason that with all this sanitation structure development, the mission for clean water has not really been 100% successful is because the human beliefs and practices. So you have to take the local people on board, have the stakeholders kind of get integrated to your policy interventions, and then, apply it. Most of the time, what I've found is much of these policies are very top-down. The bureaucrats sitting in Delhi would decide something, they would be translated to the state bureaucrats, they would do something and say, oh, it's done. In the ground, you go there, you find nothing. Because, they are all done in paper, or even if they are done in a way that is not really coming in use to the common people. A perfect example of that is the Delhi air pollution. Are you aware of it?
Yes, sir.
Like every winter now we are having all this humongous pollution of air in Delhi. It's like a gas chamber, right? Yes. Now, you think why I'm saying this? Well, the reason I'm saying is this, because through this study and many other studies, we have now realized that the Delhi air pollution is actually linked to some groundwater policy interventions that happened in Punjab, Haryana. That might be something, okay, what is that? Well, I don't have the time to explain you now, but that's the reality. Something they did to change the groundwater regime in 2009 in Punjab, Haryana has its feedback effect and now causing all the air pollution in Delhi in the winter times. So unless you think through what the feedback impacts are, what the domino effects are, you are just going to screw up something which originally was bad but not worse. So you have to go for a conjunctive use planning and also understand what the potential impacts are. So you need to do mathematical modeling, field visits, try to understand the scenario before you go for interventions, and that's lacking.
Thank you, sir.
Good afternoon, sir. My name is Dhiman Chakravarti. I'm from BSc Geology, 4th semester. Sir, you have mentioned about the contamination of arsenic into water, groundwater. Sir, my question is that specifically in India, in 1991, when these economic reforms were constructed during the Narasimha Rao government and construction started, does industrialization and urbanization has any role in contamination of groundwater, the release of industrial waste into the rivers, specifically in Ganga, Brahmaputra? They directly release the contaminated waters of factories' waters are being sent into the rivers. So does it play any role into the groundwater?
So if I understand your question, you are asking whether the industrial pollution has led to anything to with the arsenic pollution. My thought would be no. Okay? So the arsenic is mostly natural. It was there. It was there to begin with. Yes, through our practices of mostly agricultural practices, we have actually made it worse. Okay? We have tried to spread it out. The industrial waste, they typically don't have a lot of arsenic. Although they are bad, very bad, and they have other chemicals that can potentially contaminate the water. But in terms of arsenic, possibly not. Okay?
Sir, I have a question that as the groundwater is depleting and it is creating a void, so the huge structure that we are building, that is creating a sunken effect and it is creating defects in the structures, right? So how can we recharge the groundwater fast so that we can stop this sunken effect that is created by the depletion, sir?
Whereas the river valleys are more sandy, so they are not very obvious here, but if you go more toward the downstream of the rivers, both Brahmaputra and Ganga, in the delta areas, you do see a lot of problem like that. So let's say the city of Kolkata, Joshore, they are all in the delta area, and we believe they are sinking, partly because they are on clay, partly because huge volume of groundwater is being taken out. Now, to augment it, to recharge it with groundwater, people have proposed something called a technique called MAR, M-A-R, which is called managed aquifer recharge. And this managed aquifer recharge has multiple benefits that people have proposed, including stopping that sinking. However, my practical experience is that these MAR structures are good in like a local scale, maybe a village or something. But when you think like you can stop a process that is happening for a city, let's say of the dimension of Kolkata, you possibly need a few thousands of MAR. You don't have the space, you don't have the resource, right? So maybe it's on paper it is a very good plan, but in practice they may not be very effective. More than that, now since I showed you that all these ponds created these research structures and so on, I know, you and the government of India both got really excited, and they decided to create all these research structures everywhere in the country. It doesn't work that way, okay? It's not a commodity that you go in a shop and buy. It's not a packet of biscuit. It's science. And to do an intervention, an engineering intervention of this sort and this magnitude, you need to know the place really well. Several things you need to know. You being a civil engineer, you would understand you need to know, the soil properties, the rock, the sediment properties, the water circulation patterns, the climatic patterns. So if everything works out, then only you can possibly go for a, intervention. Most of the times that is not followed, and consequently, they started with a lot of like highlights, but eventually 2 years down the road, they all fail. That's the reality, okay?
Gravity thing was not known to me, so thank you so much because I'm out of touch from geology quite some time, but I think my teachers must be aware of it, Tom and Jerry. A wonderful thing I learned. I think it is not limited to groundwater, but then Tom and Jerry can also help us finding out many other things on the earth.
Yes.
So that is one. And second is that the way the groundwater levels are changing across India, I think we in the Northeast also have a major issue, but then we also have another social political issue called dams and big dams and small dams. So when you were showing the map of India and when this was showing the West, I was trying to figure out that from 2004 to this time in 20 years, a lot of groundwater recharge has happened in the Narmada Valley, which was giving irrigation to Rajasthan and also to Gujarat. So that area was having high ground because the groundwater coming to Narmada has stopped because the already water has started pouring.
That's
and
correct.
So maybe Narmada, I mean, this is just my thought. I don't
the Sabarmati region is a good example of that, yes.
Yeah, so this has an effect. So the dams are having effect on the groundwater recharge. So that we should know in Northeast that as a geologist, that the dams will bring back some portion of groundwater in due course of time. So we should not unnecessarily go by the wind and start discarding anything. So gradually it has stopped also. And there are limitations. There are other social aspects. I mean, then we have to see the social aspects are more important or living aspects are more important. This is my one temperament. Second is about this Manrega, because I was associated with that. So I will give my mind to you, maybe right or wrong, that you decide. That in 1970 to 73, we were very young, I don't remember, but my father is a man of agriculture and he was working with a sugar factory. And so I used to be very inquisitive at that point of time, use of groundwater. We used to get groundwater at 20 feet at that point of time in my village. And that is almost 200 feet now. So that is the way things have changed. But then The Manrega, before Manrega in 1970 to 73, this was a minimum guarantee program, MGM, MMGM or something. Not Mahatma Gandhi was not there, but the guarantee was there. So this MGM started in 1972. May not be for the groundwater that you said, but it was basically for drought-prone areas.
For?
Drought-prone
Okay,
areas.
okay.
So MMG started for the drought-prone areas, and drought-prone areas, it was only to dig the or clean the existing ponds or dig new ponds, and cleaning the existing pond was more important than digging the new ponds because water retention because of siltation was, hey, hello, wait, it's a serious affair. Sorry. So this was a very, very concerted effort by government in that point of time that they started doing this, and there were two components of that. One was that desiltation of the ponds will happen. Though they might have not thought, some geologists may not be part of it, but if I recall, it was not being concerted like that. It was also, there was something behind that underground water and cleaning of the pond. I mean, if you remember, we all remember our villages, every house was made up of mud before the bricks have come. And there was no problem of groundwater. Because every year they used to take mud from the ponds and they used to build their houses or clean their houses. और उसके ऊपर में तो सारा mud निकल गया, recount. So that was the concept. I'm talking with my experience. And later on, when I was with the NSS program, Government of India, when this rainwater harvesting and management of, what do you say, watershed recharge. There was a big project of Government of India in 1996-97 about watershed management.
Yes.
So this watershed management, so all those things have gradually converted into Manrega. Manrega Act came in 2005. So I just thought I give you my background of Manrega, which I know. So
Right. No, until I had an opportunity to work with, the highest administration of this country. And on doing so, talking with the various secretaries of the various departments, I realized that, it might have trickled from many of the other disciplines. But since 2004, 5, the primary, vision and mission of Manrega was to get some kind of job to these people. But like I just explained, it just happened that they were doing the right thing. So in 2017, like I said, there was a contemplation to whether continue Manrega anymore or not. And I guess these are all, grand scheme of things, not controlled by us. So this is around the time that our study got published, and it got a lot of highlights, and I was invited to talk with the highest administration of this country. I presented the data, and they were so pleasantly pleased. They said, well, we're going to continue this. And like I said, it kind of culminated to several of the projects henceforth, including the Jal Shakti Mission, the Atal Bhujal Yojana, and so on. Down the road, and I have worked with them for almost a decade now, the Jal Jeevan Mission too.
One thing also very important been done by Honorable Supreme Court of India.
The Green Tribunal,
Yeah, with respect to converting the ponds, any kind of pond which was there in the land record up to 1968.
Okay.
They cannot be converted into a, any kind of residential thing, which has happened for many years. And if you know the Uttar Pradesh now, maximum buildings which was being demolished by bulldozer is basically been built on the ponds. So this is happening across, and I think the next, especially I'm talking about West Bengal, where the maximum ponds have been encroached in West Bengal. Yeah. So that kind of thing was done there, and many states have followed it.
These are not just individual efforts. I'll tell you from my one personal experience. So if you look at the Ganga, the channel of Ganga in West Bengal, there are two prominent channels. It comes north of Kolkata, and then it bifurcates to two streams. The one that you see today, the Hooghly, and then there is an older stream which is known as Adi Ganga, like the old Ganga. It passes through the Kali temple, which we all know. Now this old Ganga channel, which is a natural channel, like people try to sell it that it was constructed by the British, but that's not the reality. British did a part of it, did excavate a part of it, just to basically desiltation. But it is a natural channel. Now, what happened during the construction of the metro rail, the year 2000 actually, and we filed, like I was working for an NGO and we together filed a case in the Green Tribunal. We did lose because we had just one lawyer who was not paid, pitted against like 17 lawyers from 17 departments of Government of India and Government of West Bengal. As of the reality of the present day, the whole metro line south of a place called Kaliganj is actually constructed on the river, on the old channel of the river. Now, during that time, and this is anecdotal, we actually wrote in the newspaper that there would be feedback effects. People just asked us, "Oh, you are just anti-development. You have a specific political affiliation and blah blah blah." 20 years down the road, now they are realizing what he said, because during the monsoon time, the whole area gets flooded, full of mosquitoes, all kind of enteric diseases. Now they are realizing what he said, but you cannot roll back now. You cannot demolish the whole metro structure. So if you're talking about encroachment, that's a government-sponsored encroachment of a river, right? So this is the story of India. You cannot go away from it. We have to just find out the best alternate route.
You must be landed in Guwahati today or yesterday?
Yesterday night, yes.
So when you land in Guwahati or Calcutta, as a geologist, what I see the most is oxbow lakes.
Yes.
And they are all visible from here. You need not to have remote sensing data for that.
Yes.
From your naked eyes, you can see this was the Oxbow Lake that has been encroached by people around.
Absolutely.
So I think somehow or other, geology is my discipline, though I later on joined strategy, but my heart is still of geologist. I think all policy making of this country should not be done without one geologist at least.
Yeah, that's a very good point, and I was just going to add up. So the problem is, you talk about geology, you talk about physics, you talk about chemistry, the sciences that we learn from our childhood till the day. When you go for management, the strategy implications, none of them are followed. Nowadays, biologists, Professor Ganguly would be very happy. Biology is little bit used because of the COVID exposure that we had, and we now realized what the importance of basic science is. But if you take about the other subjects like physics, chemistry, maths, geology, where are they used? None, nowhere. Although they are inherent to all the policies that it should have been. And that's the fallacy of after 75 years of our independence. Now, I have worked extensively in the Western worlds. I still do. And one of the good things that I get to see that, a few years back, there was a major bridge collapse in the I-10, which is the main highway between Canada and the US, going to Texas, Florida. When this bridge collapse happened, they started digging out, like, what has been any study? What it was found, that it was not a government study that was done, but in 1978, there was a PhD thesis, possibly done by University of Chicago, on that bridge. They dig out that thesis. They started realizing what was built. Eventually, they took it as the source for fixing the bridge. Now, do you ever think that that's going to happen in India? No. So that's the reality. So one of the things I tell my students, my peers, who don't really like me on that, is that we scientists also need to talk to policymakers. We need to talk to social scientists, because they are extremely important in communication. We never try to do that. And I made it a mission to do that, to talk to policymakers and like the social scientists, the communicators, because they are much better communicators than we are. We can write papers, scientific papers, which may not mean anything to the common people. So, I get patted on my back all the time that today my news came up in one of the, local newspaper like Ahmad Bazaar or Hindustan Times. They never, acknowledge the paper that was published in a very good journal, because they don't understand that, which is absolutely fine. So it is extremely important that as we do science, irrespective of geology or physics or chemistry, you take out the bullets out of it, talk to a social scientist or a communicator, talk to the media, talk to the policymakers, because that's the only way that is left that we can influence the society. Thank you.
Good afternoon, sir. I'm from Geology department. And my question is, in Assam, Karbi Hills, there are granitoid plutons, and these granites, and these granites have high concentration of uranium, as found from the reports. So I want to ask how these granites will affect the groundwater.
Okay, that's a future question. So, but that's a very right question too. So uranium, it's just like arsenic or iron or whatever. It's actually, it's parts of the minerals. And granites are known to it, as you know, like they would definitely be present in feldspars, potassium feldspars, which are the most common mineral on the surface of Earth. So they are nothing foreign about it. What we were in denial till 2024, and possibly till the date, is that none of this can come in the groundwater. The reality is, so Assam, so this Brahmaputra basin has a very interesting problem. That's why kind of it got me excited and I started working here. So you have these Himalayan sediments, that are coming not from the Brahmaputra, but coming through the northern rivers, like passing through Lakhimpur, what's the river? Basically, Subansiri, Subansiri, and all these northern rivers, right? They bring down the sediments from the Himalayas, or the Shivaliks rather, which are laden with arsenic. The southern rivers also do. I was just explaining, I think, your professor yesterday, that southern rivers also do. Like Dhanshiri, I know, I was working in Dhanshiri just last couple of months back. That also has a lot of arsenic problem. Not only arsenic, you have chromium, you have nickel, possibly also uranium, okay? So definitely these rocks do give out these contaminants. However, they are redox sensitive. These elements are redox based on the chemistry. So whether they would be present in the solution form, which is groundwater, versus they would be in the solid form, which is the minerals, that depends on a very delicate redox chemistry or bioredox chemistry. It's a redox chemistry that is tremendously influenced by biological phenomena. That's why I said that I'm also learning biology now. So it is actually the microbes that controls the redox system. Now, saying that, you also have the basement of where I'm standing now, which are the cratons, the cratonic granites, right? Including the Nilachal Hills and Umashankar and all this. These are the basement rocks that are exposed. And these basement rocks, including the granites, they are known to be having fluoride or fluorine in apatites as accessory minerals. Given a scenario, you have to have a proper hydrometeorologic condition, this fluoride gets released. So in many areas of the Brahmaputra basin, if not uranium, which is not yet very well known, you have coexistence of arsenic coming from the Himalayas, fluorine from down below. So it's a pretty interesting scenario where human intervention has happened, but not to that extent like in other parts of the country. But you have all these natural elements getting released to the groundwater system based on the geological processes. Okay?
Thank you, sir.
Sure.
Hello, sir. I'm Saurabh from Department of Geography. Sir, I have this one small question.
Okay.
Sir, as we all know that India has the largest population in the world, and it is continuously increasing. And to feed this huge population, we need to increase our food production.
Absolutely.
And to increase our food production, we need to increase our irrigation facility. And most of our irrigation water comes from groundwater, which is more than 60%. So, sir, how can we make this balance so that our food production doesn't go down and our water level also?
Right. So,
Yeah,
something that I sometimes say in my other presentations, like the irrigation that is being done in this country, the cultivation, the methods, do you think they are very modern? I like to say that the principles in which irrigation and cultivation happens in this country and the subcontinent in general, they are still the same that our forefathers used to do in the times of Indus Valley. They have not really evolved in the last 5,000 plus years. We still use so if you go and ask to a farmer, I have done it so many times, what I ask, like, why do you do this? My father did that. If the father is still alive, you go and ask him, my father did that. So it's a legacy thing. It's not because they are aware or unaware of the system, it's because it's a family tradition. And if you add them up, it's the general method for most of the farmers in this country. It's not that they are averse to modern technology, it's just because it's a tradition. And these traditions were good for a few thousands people, maybe a few lakhs of people, but possibly not really good for 1.5 billion people. So we need to have a revolution in terms of modernizing the agricultural practices. I worked in Texas for a long time. I worked in Israel. I have collaborators out there. These are dry places like deserts. You still have basmati growing in those places. They don't call it basmati because of legalities. They call it texmati. Okay? But they have plenty of texmati growing everywhere. And how do they grow? Because basmati is an extremely water-intensive crop. The reason is they have modified their agricultural practices, irrigation practices. So as we are learning all these modern things, we have a smartphone in our hand all the time, which is very smart. We also need to go for smart agriculture. That's the future.
Thank you so much, sir. It has been an eye-opening session for many. I'm sure getting enlightened in one very alarming issue that it is we are presently in today. I request Professor B.S. Mipun, Dean, Royal School of Environmental and Earth Sciences and TSW to extend a vote of thanks. Sir?
This speech is never going to end because students are so enthusiastic. They have learned a lot of about groundwater scenario of India, about the world, and so much so that not only he spoke, but also he has illustratively presented. It will be so beneficial for the students of ours, geographers, geologists, and the science, and environmentalists. Those who are sitting here, I'm sure they have been extremely benefited out of your talk. This was a very elaborative talk and also illustrative talk. And you have spoken about the entire groundwater scenario of India, pollution, agriculture pollution, arsenic pollution, and also about coliform pollution, and about how this has been managed and how this can be monitored. That also he has shown you with the help of remote sensing techniques. So since he has been working with NASA, so that's why he could show you how this kind of new technologies can help us in preserving our groundwater resources. Because until and unless we know what is the scenario, then nobody will think about how to preserve them. So that's why this kind of presentation is very important for us, that how much we have been, there is a depletion of groundwater. So there may be research, but that research is not sufficient for the future. So a future scenario is going to be very bleak. So that's why everybody should use water judiciously. And also agriculture also you have told about that how we should modernize agriculture. Not only this kind of modern agriculture is not sufficient. So we have to modernize so much so that irrigation will be there, but groundwater depletion will not be there. So that is the lesson we have learned from this lecture. And also policy interventions are also needed to be modified. That is what, when you become a policy maker, like Professor, our SP Singh sir has told you that we need a geologist, we need an environmentalist, we need a social scientist. Yes, we need a geographer, you need a geologist, we need an engineer to make policies. So we should not allow only the politicians to make policies, so we should be also there one day or other day to make this India or make this country a groundwater depletion free. So for this, bringing Professor Abhijit Mukherjee, first credit goes to Professor Ankur Ganguly, the Dean Academics, because of your acquaintance, we could bring him here, because he is so eminent scholar, Santishoro Bhatnagar awardee, and you have seen his profile and how much he has been busy everywhere. So from one country to another country, he has been visiting and also writing, research papers. So with this busy schedule also, you could make it to us. So from my, side, from my part, and also from Royal Global University, I like to extend my formal vote of thanks. That thank you for accepting our invitation and giving us so much valuable inputs to our students and to teachers and the faculty members. And I am sure Royal Global University has enriched a lot of knowledge by listening to you on today's lecture. And also like to thank our Vice Chancellor, Professor S.P. Singh, our Chairperson, Professor Alok Buragohai, and colleagues of this university, the students, the media, those who have covered the entire talk about groundwater depletion, groundwater pollution, groundwater control, groundwater preservation, and also policy intervention. So we like to thank you so much once again. Thank you, sir, for accepting our invitation and giving us this so much time for us. Thank you.